In this lesson, we're going to talk about how we simplify a square root. And the first thing we need to talk about is what's legal. Well, consider the square root of 25. Okay, what is the square root of 25? Well, what number times itself is 25? It's the number 5. Okay, so the square root of 25 is 5. Remember that. We're going to use this as the base, our anchor for what we're going to talk about. Okay, we know that the square root of 25 equals 5. My question is, can we split up a radical over addition? What do I mean by that? Well, notice that 25 is the same thing as 16 plus 9, right? There's nothing controversial there. But my question is, can I split up the square root of 16 plus 9 into the square root of 16 plus the square root of 9? Is this statement true? Well, what is the square root of 16? The square root of 16 is the number 4. What is the square root of 9? The square root of 9 is the number 3. Okay, so the square root of 16 plus the square root of 9 is 4 plus 3, which is 7. This is a problem because 7 is different than 5. So what do we learn? Well, even though 25 equals 16 plus 9, we cannot say that. Let me circle it here. We cannot say that the square root of 16 equals, that the square root of 16 plus 9 equals the square root of 16 plus the square root of 9. Alright, because this equals 5, right? The square root of 25 is 5, and this equals 7. So it's not some arbitrary rule people came up with. It's just literally numbers don't work that way. You can't do it. What about splitting up over multiplication? We know you cannot split up over addition, but can you split up over multiplication? Well, let's look at an example. Consider the number 36, and here I want this to be your anchor example. What is the square root of 36? It's the number 6. Okay, so this is your anchor for this part of the discussion. We know that the square root of 36 is 6. Here's my question. You can think of 36 as 4 times 9. So my question is, there's nothing controversial here. I know that 36 is 4 times 9. And I know that just means that the square root of 36 equals the square root of 4 times 9. Nothing controversial yet. Here's where the question comes in. Can I split this up? Can I split up over multiplication? Can I write the square root of 4 times this as this? Can I write the square root of 4 times 9 as the square root of 4 times square root of 9? Well, what is square root of 4? It's the number 2. What is square root of 9? It's the number 3. So I get 2 times 3, which is 6. Notice, I get the same answer if I split up the radical as I did in the beginning. So what does this tell us? Well, this tells us that radicals split over multiplication, or square roots split over multiplication. How does that help us? Well, first we need to get a list of numbers that play nice with square roots. Okay, so what numbers play nice with square roots? 4 does, 9 does, 6 does, 25. Where do these numbers come from? Well, 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. So that's where this list of numbers comes from. You can make your own list. Okay, these are just numbers that it's easy to take the square root of. Take a number from this list, like 121. Why is 121 in this list? Because the square root of 121 is 11. So that's what these numbers are. These are going to be our players that help us break down a number when we're talking about square roots. How does this work? Well, consider the number 18. Let's try simplifying the square root of 18. What you're going to do is, what do you do with this list of numbers? What you do is you ask which of these numbers goes into 18. Okay, and you want to pick the biggest one. So let's take a calculator. I don't need it here, and you probably don't need it here either. But let me just show you how you would do this for bigger numbers using a calculator. So I'm going to take 18, I'm going to divide it by 4. Does it go in evenly? No. I'm going to take 18, I'm going to divide it by 9. Does it go in evenly? Yes. So I'm going to keep going though because I want the biggest number. I'm going to take 18 and divide it by 16. Does it go in evenly? No. And I can stop. I don't have to keep checking because these numbers are bigger. 25 is bigger than 18, so I don't have to check those numbers. Okay, so to recap, I learned that 18 is divisible by 9, and I kept checking because you want to use the biggest player. You want to use the biggest perfect square. In this case, 9 is the only perfect square that goes into 18, so that's what I'm going to use. Okay, does 4 go into 18? Now, how about 9? How about 16? How about 25? So these are the questions you ask. Now, we asked those questions, and we found out that the number 9 goes into 18. Okay, so I'm going to write 18 as 9 times 2. Now, for some reason, students think that you just want to write 18 as a number times a number. Like, oh, I need to write 18 as 6 times 3. No, that's not the point. The point is these numbers. The point is using these players. So it doesn't matter that 2 divides 18. That's incidental. That just happened to be. What really matters, the key that's going to help us is this 9. That's why we check these numbers. These are the numbers that matter when you're trying to simplify a square root. Why? Well, remember, we can split a square root up over multiplication. So square root of 9 times 2 is okay to write as the square root of 9 times the square root of 2. And since we cleverly chose numbers from our player list up here, now that I've split this up, I can easily take the square root of 9. The square root of 9 is simply the number 3. So, square root of 18 equals 3 times 2. And notice what we have left in here, this number 2, none of these go into it. Alright, so it's completely simplified. And the reason that is because we always check for the biggest number that will go into your original. Let me show you the next example where this matters. Where this actually comes up. Consider the square root of 80. Again, we play the same game. Does 4 go into 80? How about 9? How about 16? How about 25? You're not just trying to write 80 as, oh, let me write 80 as 8 times 10. 8 doesn't matter. 10 doesn't matter. You don't care about those numbers. You only care about these players. 4, 9, 16, 25. Anyway, so we start the same way. We start asking these questions. And let me bring the calculator into the picture here. So I take 80 and I divide it by 4. Notice 4 goes into 80 evenly, but I don't want to stop there. Keep checking because you want to find the biggest player that goes into it, not just any number. So let's check 9 next. Does 9 go into 80? Nope. What about 16? Does 16 go into 80? Yes, it does. Okay, 16 goes into 80. Let's keep checking. What about 25? No. What about 36? No. What about 49? No. And I'm bigger than half of 80, so I can stop. But anyway, you can keep checking if you want. And as you do these, you'll kind of start seeing patterns and get more comfortable with them. But I just wanted to show you the long way how I do these. Because it's likely how you'll do them in the beginning. And then after a while, you probably won't. So anyway, I found out that 16 is the biggest perfect square that goes into 80. And it goes into it 5 times. So the number 16 goes into 80. Now, I'm going to write the square root of 80 as the square root of 16 times 5. Again, it's not that I just want to write 80 as a number times a number. I specifically want to know what perfect squares go into 80. So it wouldn't help to write 80 as 8 times 10. That'd be a waste of time. It turns out, though, that 16 goes into 80. So I can write 80 as 16 times 5. And I can split that up as square root of 16 times the square root of 5. And again, what's nice about these numbers is that you can take the square root of them easily. So the square root of 16 is simply the number 4. Okay, so it turns out that the square root of 80 is 4 times the square root of 5. And you look at 5 and notice that no perfect squares go into 5. You can't divide 5 by 4, or 9, or 16. So we're done. Square root of 80 equals 4 square root of 5. So that's how you simplify a radical. You don't just plug square root of 80 into your calculator because you're going to get the wrong answer. What you do is you make yourself this list of numbers, And then these are the numbers that are going to help you break down a square root.